Alright, so here's the last of the videos that we're going to look at tonight. And we're going to finish up one coordinate problem, and then we're going to fill in some more information on our graphic organizer that we've been working on. Alright, so in 9, it says verify that EFGH is a trapezoid. Alright, so first thing that I look at with these is I'm going to start them the same way I did with our parallelogram problems, and I'm going to draw a quick sketch. Now, the sketch just needs to be good enough that you can get the relative positions of these. Alright, so don't strive for a perfect graph here. A quick graph is totally fine. Alright, just make sure you label as you go. Alright, so we've got 8 and then -5. Alright, and then the last one here is -4 and 4. So up there. Alright, so when I see this, alright, I'm going to go ahead and connect those so that I get a quadrilateral. Alright, and again, we're not shooting for perfect. We're just shooting for enough that we can make some decisions on what we're going to test. Alright, so I have EFGH, alright, going around. Now, to be honest with this one, I'm going to go ahead. I typically would be looking at this from a perspective of what shape is it, not just is it a trapezoid. So I would still start the same way that I always have before, which is with the slopes. So I'm going to do EF first. Alright, so EF, I have 0 minus 3 in top, and I have 5 minus 1 in bottom. Alright, which is going to give me a -3 over 4. Alright, then I'm going to go slope of the opposite side, which is HG. Alright, and on HG, I've got 4 minus -5 on top, and -4 minus 8 on bottom. Alright, that's going to be 4 plus 5, so 9 on top, and -12 on bottom, which if I reduce that, divide out of 3, I've got -3/4. Alright, so right there I've got one pair of parallel sides. Alright, but I'm going to now confirm that it's not a parallelogram, and it is in fact only a trapezoid. Alright, so I'm going to do my slopes on EH. Alright, so if I go with EH, I've got 4 minus 3 for the change in Y, and I've got -4 minus 1, right, for the change in X. So that's going to be 1 over -5, or -1/5. Alright, right there I know it's not a rectangle. Alright, because I have slopes on the adjacent sides that are not opposite reciprocals. So now I'm going to go with measure of FG, alright, which is our other one. And on FG, it looks like we're going to have the middle two there, so -5 minus 0 over 8 minus 5, alright, which is going to be -5/3. Alright, so those two are not the same, EH and FG. Alright, so this would have to be a trapezoid. Alright, so EFGH must be a trapezoid. Sorry. Alright, because it has exactly one pair opposite sides parallel, right? Which is the definition of a trapezoid. Now, I'm going to go ahead at this point, now that I've ruled out parallelogram, I don't need to check to see if it's a rhombus or a rectangle or any of that. Alright, because once parallelogram's ruled out, so is all the shapes that are underneath that. But what I do want to check for now is I want to check and see if this is actually isosceles. Alright, so this is where I'm going to change course a little bit from if I determined if it was a parallelogram. If I determined this was a parallelogram, the next thing I do would be check two adjacent sides. Alright, but because we ruled out parallelogram, alright, now all we're going to do is we're going to check opposite sides length to make sure or determine if they're congruent. Now, I lean on the picture to choose. All right, in this, the two that have the chance of looking congruent are HE, right, and FG. So those two edges here and here are the two chances, two places where we could have congruent legs. All right, we always want to check the legs. We know the other two are the parallel sides, so we're going to go into the legs. So I'm going to do the length of HE, so DHE, and if I do that, we've got square root, right, H and E, the last and the first, so I've got negative 4 minus 1 squared plus 4 minus 3 squared, which gives me 25 plus 1, or root 26. All right, so that's HE. So now I'm going to go in and do D of FG, because I want to find that distance. All right, so FG, the middle two there. So for x's, I've got 5 minus 8, quantity squared, plus, for the others, I've got 0 minus 5, so 0 minus negative 5, quantity squared. All right, because we're doing FG, so we're using this point and this point. So change in x's are 5 minus 8, and change in y's are going to be 0 minus negative 5, and we get this set up. Now that's going to be a square root of a 9 plus a 25, which is a square root of 34. All right, those two are not congruent, so we are not isosceles. All right, so it must be a trapezoid, but even further than that, we can rule out it being really any of the other shapes. All right, it is solely a trapezoid, not an isosceles trapezoid. All right, so that was one of these. Let's jump to the graphic organizer just real quick. All right, today we focused on trapezoids. So if I look at trapezoids, all right, that's this side over here. So in a trapezoid, we have one pair, opposite sides, parallel. All right, one pair, opposite sides, parallel. All right, the mid-segment, mid-segment is half the sum of the bases. All right, and that's really just about it that we get from a trapezoid. I guess the only other one that we could say is we could say that consecutive angles on the inside, like if I had x and y here, between the bases, are supplementary. So in this picture, if I call that xy and zw, we could say x plus y equals 180, and z plus w equals 180. Now, reality is I probably wouldn't put these on the flowchart. All right, and the reason why I wouldn't do that is they actually come from other properties we already know. If these are parallel lines, then I have parallel lines cut by a transversal, and we know consecutive interior angles are supplementary. All right, so this is our trapezoid. And then this is our isosceles trapezoid. All right, and an isosceles trapezoid, we do get a couple other options. All right, base angles are congruent. All right, legs are congruent. Diagonals are congruent. All right, and we get those properties. So we know that we can mark a congruence here, this base angle to this base angle, those two base angles together. All right, but then we could also know that the diagonal this way and the diagonal this way are the same. All right, so that takes us through that graphic organizer. That leaves us with one shape left to address, which we'll address on Thursday. All right, and then from there, we'll progress in to review. And we'll review for Friday of this week during our session. And then we will review next week, Monday and Tuesday together. Wednesday and Thursday will be our test days. All right, so that takes us through today's lesson. From here, your homework tonight is the 6A homework. It's a pretty quick one. Um, you've got some really algebraic problems. You do have a coordinate geometry problem, and then a couple more that deal with mid-segment. All right, so in this one, I'm going to actually say odd. I think odd is more than sufficient on that. So just the odds on this one. So it's going to be a pretty quick assignment, but it covers what you need to understand how to do. All right, so I hope that helps. I will see you in class tomorrow.